Good. So we had a similar example last time. So let's do this one as well. So the difference quotient has to be memorized moving forward. It's f of x plus h minus f of x divided by h. We discussed this. It's so important that we discuss it on the first day of classes. Okay. So there is no problem. I know how to evaluate this. So it's 1 over x plus h plus 5 squared minus 1 over x plus 5 squared divided by h. Is this okay so far? Is that okay so far? Everyone? Is that a yes? Moving on, or?
Yep.
Okay, perfect. I have to find the least common denominator. Remember, two things have to happen. From the top, all terms without h must go away. If some terms with h go away, it's even better, but not necessarily. It will not happen automatically. I mean, it's not required. And then eventually this will go away. So can anyone give us the least common denominator for the top? John and Kivonia, I can see you. 1, 2, 3. Welcome. Okay, least common denominator. Anyone?
Is it n?
Say it again.
Is it n?
Okay, so we have to discuss that. So let's talk about LCD. If I have one, let's say 1 over, like we had 1 over 7 plus 1 over 6, but let me just say another. 1/3 minus 1/4. These two have nothing in common. 3 and 4 have nothing in common. Every time I add or subtract fractions whose denominators have nothing in common, it must be the product of the two. So there are basically 3 situations. When the two denominators, and I can go over all of them if you'd like. So one situation is when the denominators have no common factors. Another one, when the denominators have common factors. And the third and the last option is when one is divisible by the other. So in this case, I chose an example with 2 factors that have nothing in common, which means that I multiply 3 by 4, I have to multiply the numerator by 4. I multiply 4 by 3 to get 12, so I have to multiply the numerator by 3. 4 times 1 is 4, minus 3 times 1 is 3, so I combine like terms, perform the operations, and I get 1 over 12. So coming back here, that's the reason why I chose this example, is that these 2 factors have nothing in common. Nothing. You cannot multiply this to get this by anything also, and they are completely factored if you want. There is nothing common here. So then the least common denominator must be the product of the 2. It's a must. They have nothing in common, it must be the product. This was multiplied by x plus 5 squared. So the numerator has to be multiplied by x plus 5 squared. This was multiplied by this. So the numerator has to be multiplied by x plus h plus 5 squared. This times this minus this times this. So we have 2 options here. I write them as is and then factor, which would be the easiest. Or I square this and subtract the result after I square this. Which one you would feel more comfortable with? The one with factoring or the one with squaring?
Square.
Okay. So in that case, let's write them first like this. And this is h over 1, so I will flip the denominator. We discussed that last time. That's how we divide fractions. We copy the numerator, and we multiply by the multiplicative inverse of the denominator. We never multiply or expand the factors in the denominator, ever. Do not touch this. I flipped 1 over h because that's the rule for dividing fractions. I copied the top fraction, and I flipped the bottom fraction. So now when I square x plus 5, what do I get? I'm not going to have enough room here, so I'm going to write it again. So how many terms do we get when we square x plus 5?
3 terms.
Excellent. Thank you very much. Thank you. You made me very proud. And they are x squared plus 2xh plus h squared. Now, when I multiply x plus h minus 5 by x plus h minus 5, we don't use a formula for that normally. We have to multiply them on the side. So I'm going to multiply x plus h plus 5 times x plus h plus 5. X times x, x squared. X times h, x times 5. H times x.
I'm sorry, on the paper,
It's minus. Yes, I see it. Thank you. I wrote plus. Thank you. No, I wasn't trying to see whether you were asleep. I was asleep, and I don't know where my whiteout went. Thank you. Yes, it's minus. It's not plus. Where is my whiteout? Oh, on the floor. Got it. Thank you very much. Thank you. Thank you. So is x squared xh minus 5x plus xh plus h squared minus 5h.
I think that could be plus 5 of the x that they want.
Say it again.
Because the question is that 1 over comma is plus 5 and then...
Oh, it is plus 5.
So...
Oh, here I had minus. Here I may have minus. I got it. Okay. Got it.
Yes.
Um,
And then it's also plus 5.
It's all plus. Yes. I corrected everywhere. It's plus here. It's plus everywhere. Thank you very much. Yes. So x squared plus xh plus 5x plus xh plus h squared plus 5h plus 5x plus 5h and plus 25. So finally, this is this squared. Now I have to distribute -1 to all terms. Let's combine like terms first. So x squared is by itself. Xh, 2xh, 5x plus 5x, 10x, and then plus 10h, and then plus h squared, and plus 25. Finally, we can put it in there. So all with minus. Minus x squared, minus 2xh, minus 10x, minus 10h, minus h squared, and minus 25. So the first one was x squared plus 10x, xh, plus 25. Please make the correction. I talk too much. That's what it is. So this is 10xh because it's x plus 5. X plus 5 squared, so it's 10x So x squared plus 10x plus 25. I realized that something was wrong right away because my terms are not canceling out. And no, I was not trying to check whether you were paying attention. No, I wasn't paying attention. Okay, so these two must go away, these two must go away, and these two must go away. Now the top has h, all the remaining terms must have h in common because the denominator this will go away. So we have a negative 2x, we have a negative 10, and we have a negative h. Final simplified form, negative in front, 2x plus 10 plus h over x plus 5 squared, x plus h plus 5 squared. And this is it. Any questions?
How would it be different if you factored it?
Oh, very good. Awesome. I'm glad you asked. So, for factoring, I'm going back here. The difference of squares factors into a plus b times a minus b. So this is this way, and then factoring is this way. A squared minus b squared will be a plus b times a minus b. Much easier. Way easier. So I'm going to just go back to this step. Okay, so when we have x plus 5 squared minus x plus h plus 5 squared, everything over h, x plus 5 squared, x plus h plus 5 squared. If in your wildest dreams you try to simplify these two or simplify these two, there will be a tragedy. Because this is a term here, and this is a factor here. You cannot simplify a term with a factor. You can only simplify terms. I'm sorry, not terms. You can only simplify factors. You cannot simplify terms. Okay, so knowing the formula that we just reviewed, which is the difference of squares, I wrote that so I can get it out of the way. First term minus the second term. X plus 5 plus x plus h plus 5. First term. But minus the second term. And I don't need to multiply anything. These two will go away. These two will go away. The negative h is in front. 2x plus h plus 10, everything divided by h, x plus 5 squared, x plus h plus 5 squared, and you're done. I would have never multiplied, but you chose that. That's fine. The answer has to be the same. But this is in a blink. And this is, it took me like forever. I even copied it wrongly. Twice. Thank you for paying attention. Because then I would have gone back to find my mistake. So yes, factoring. So always keep in mind two keywords or concepts. Factor and simplify. You should always have this in the back of your mind at any point in time. Thank you for asking. Good, very good question. Everyone needed to see that, I'm sure. Perfect. You understand that this is not difficult to square, but this is more difficult because it has 3 terms. This, we apply the special product right away, but here we have 6 terms that they collapse into less terms after we combine like terms, etc., etc. Very good question. Okay. Moving on, so we can try and finalize R.3 so we can move on to R.4. Other questions for me? Thank you for bringing this to class. Who was that? Who asked about this? No one. Okay. Well, thank you to no one for asking this. Other questions for me? Other questions? Yes?
I'm still confused how you did the factoring.
I used the special product. A squared minus b squared. A squared minus b squared into a plus b times a minus b. A plus b. A minus b.
Okay, thank you.
Thank you. Anything else? Other questions for me? Okay, perfect. So I have a few other things that I would like to look at. We determined the domain of this function. We can also look at 50. So 50 on page 32. It's another function that I would like to analyze for a moment, since you asked the question from before. So what type of function is this, and how do I find its domain? What type of function is it? Anyone? Can anyone tell us what type of function is it? Are we on strike today?
Rational.
Thank you very much. It is a rational function. Very good. So as we know from before, x squared minus 36 cannot be 0. You either factor or you take 36 and take square roots. So let's say we factor and we get x minus 6 and x plus 6. And this cannot be 0, so then x cannot be 6 and x cannot be negative 6. In interval notation, any questions for me? So in interval notation, the domain will be written as negative infinity to negative 6, without negative 6, union without negative 6 to 6, without 6, union 6 to infinity. In plain English, everything but 6 or negative 6. Okay, so that's how we write the domain of that. I think we had enough domains, unless you find something that we haven't discussed, but I don't think so. And now let's read from any graph. I was looking at 25, 24, and 31. On page 32, I hope you have page 32 brought up. Would you like to select? Are these okay with you? We want to determine the domain, the range, and some values from the graph. So they want to find x value such that f of x is 2, and domain and range, and f of 1 for all of them. Okay, since you're not cooperating really with me today, I'm going to look at 24 on page 32. So I see that this function has only dots, only points. It's not a connected function like these. It just has points, and I'm not allowed to connect them. So I'm going to graph them for those of you who don't have my lab math open up. So because you may not see this, that's the only concern I have. Here's one point. Here is another. Here's another. One more here. 2 here. And one more here. So of course, negative 5 to 4 and negative 5, I think it is, yes, to 5. Can anyone identify the domain of this function for us? And then the range. And then we're asked to find f of 1. And then we're asked to find x such that f of x is 2. Say that again.
The domain would just be each individual point, right?
Exactly, and we have to write them with braces. We cannot use for finite elements. We have to use braces. It's not the set builder notation, but we have to use braces. We cannot use parentheses or brackets. So I have to list negative 5. I have to list negative 4. Negative 2, 0, 1, 3, and 4. Perfect, excellent. The same thing for the range. So I have to list negative 5. I have to list negative 2, 0, 2, and 5. And now I have to answer the question, how much is f of 1? So I imagine that I draw a vertical line that represents x equals 1. The line crosses the graph of the function in a point at 2. Now here I'm asked to find x when y is 2. So now I imagine that I draw a horizontal line that represents y equals 2. And I will be reading these two x values. So 1 and 3. So here we have two answers, x equals 1 and x equals 3. If you want to give the ordered pairs, for this one you will give 1, 2. Of course 1, 2 again for this, and 3, 2, x is first, y is second. And we answered that question. So if you'd like to look at page 32 and tell me whether you want to see 23 and 31. If not, we'll move on to a word problem. Do we want to see 20, what was it? 25. So we did 24. So I'm looking at 25 and 31. One or both?
Can you do one more?
Yes, please choose. 25. I was looking at 25 or 31. Any preference?